Yes, morning students. Today we want to look at trigonometry, an introduction, right? It says the trigonometric ratios of an acute angle, that is sine, cosine, and tangent, are defined in terms of the hypotenuse, opposite and adjacent sides of a right angle triangle. So you should be familiar with a right angle triangle, right? Where this symbol here, this sign here, indicates it's a right angle triangle. This line, this side is perpendicular to this side, which means that these two sides are at right angles to each other, right? So in this right angle triangle, the longest side is called the hypotenuse, and it is opposite the right angle triangle, opposite the right angle, which is 90 degrees. The next longest side is the adjacent, and this is the opposite side. Opposite side to this angle, this is known as theta. So there is sine theta, there is cosine theta, and there is tangent theta. And these are all expressed in ratios. A ratio is like a fraction, and something over something. So if you look over here, you see that sine theta, the sine of the angle, will be equal to the opposite over the hypotenuse. So whatever value is placed here, and here, and here, there are different ratios that will express the angles. Alright, so cosine theta is going to be adjacent over hypotenuse. This cosine theta is going to be equal to adjacent over the hypotenuse, while sine theta is going to be equal to opposite over hypotenuse. The only one that does not involve the hypotenuse is the tangent, and that is equal to the opposite over adjacent, right? So they're going to be putting the opposite over the adjacent for the tangent. So now we have three basic ways to actually calculate an angle. If this is not given, you can use the two sides, any two sides, to calculate the angle. So we have to know, based upon what value is given for the sides, what ratio we're going to use to calculate the angle. So this will be tan theta, tangent theta, right? There's a little memory jog I use here, where so ka to a. This is for sine, which is opposite over hypotenuse. This is for cosine, which is adjacent over hypotenuse. And this is for tangent, which means opposite over adjacent. So we're going to look at an exercise now. In exercise 22a, in the figure below, write down the ratios. Right? So of tan alpha, sine alpha, and cosine alpha in terms of p, q, x, y, and z, right? So these will be the letters assigned to the sides of the triangle, and sometimes you have more. Sometimes you have two triangles in one. So look carefully at the figure, right? Here we have a compound figure where we have two triangles. As a matter of fact, three triangles. The bigger the outside triangle, this, and two inner triangles, right? And we're asked to find, as much as possible, sine, cosine, and tan alpha from this triangle, and the sine, cosine, and tangent alpha from this triangle as well as this triangle. So we're going to end up finding three different alphas. So let's go. So let's label our diagram. A, B, C, and D. Right? So if we're going to concentrate on A, B, C first, so we're going to say it in, right? we're going to say now that we're going to work with this triangle first. And we're going to try and work out the ratios for this alpha. Just imagine that this triangle is, we can actually see the position of this triangle. This will be the opposite, this will be the hypotenuse, and this will be the adjacent for this sine alpha. So let's begin. So we're going to work with sine alpha first. And sine for short, sine alpha will be what now? Sine opposite over hypotenuse. That means we're going to get y over x. That's going to be equal to y. We have cosine alpha now. Cosine alpha will be what now? Cosine alpha from this triangle will be equal to what? Z over x, because it's the adjacent. Adjacent means that this side is beside the angle, right? That's what the word adjacent means. So it will be z over x. And then for tangent now, tan alpha is going to be what? For this triangle is going to be what? Remember what tan is? Tan is opposite over adjacent. So the tan alpha is going to be y over z. Okay, it's going to be y over z. So this is for triangle ABC. So this covers triangle ABC, right? Now let's work out the one for this small triangle now. So we're going to work out, we're going to have two triangles, this one and the big one for the alpha, right? This one and the big one for the alpha. You'll be surprised to see how many ways you can find the ratios. So we're going to work with this other triangle now. So for the other triangle is going to be what? For triangle ACD. So let's work with ACD. We're going to work with sine alpha, cosine alpha, and tan alpha are going to be equal to what? Let's work with the sine first. You remember that sine for this smaller triangle? Sine is what? Opposite over hypotenuse. So that will be z over q. Cosine now will be adjacent over hypotenuse. So that will be p over q. And tan alpha, remember, is opposite over adjacent, so that will be what? Z over P. It's all about remembering the ratios, you know. Once you remember the ratios, that's why you need to go back to SOHCAHTOA, right? These will help you to remember the ratios. And remember that these are just the basic ratios. There are different types of ratios in trigonometry, all right? So we're going to look for the bigger triangle now. We're going to look for ABD. So let's focus on ABD over here now. The bigger triangle, ABD. The sine alpha is going to be equal to cosine alpha. Then we have tan alpha. For this bigger triangle now, this would be the hypotenuse, right? So for this now, for sine now, we're going to begin with what? Opposite over hypotenuse. But be careful now, the hypotenuse here is both x plus p, the entire length. Watch very carefully now. So this is what? So sine alpha for the biggest triangle will be x over opposite over hypotenuse, which is x plus p. So this is going to be over is going to be x over y plus p. I want you to still a logic, you know. Y plus p is the length of this entire thing, and this is the opposite. For cosine now, it's going to be adjacent over hypotenuse. It's going to be q over y plus p. It's going to be q over y plus p. And tangent now, as you know, is opposite over adjacent. Tan will be opposite over adjacent. That will be x over q. It will be x over q. This is just an introduction, you know, to show you how to find the ratios of these angles. Alright? Thanks for watching this video. Next time we're going to be looking at how you can use these ratios now to find the angles and sides of unknown sides and unknown angles in triangles.